I've never run into these before, but I could be wrong. I guess it kind of depends on what types of things you've done. Oh, this room is so much warmer than I was expecting. I purposely wore a jacket because I thought it'd be hot. Or I mean, thought it'd be cold. Well, yeah, I know. It was warm, so I figured they'd have the air on for the first time, but nope.
Removable jacket so you can take it off and then put it back on when it doesn't.
Yeah, but I wore an old T-shirt, so it wasn't intended in being seen today. It's one of it's the purple Eastridge one. Doesn't look great. I wear it for like working on the car and stuff like. Okay, if all goes well, and honestly, what I'm anticipating happening is we'll take the notes today. I'm not going to fly through them, especially because this is a new topic. Most likely, we'll have tomorrow to work on the homework. I've already posted it, but you don't need to start it. So I'm kind of anticipating that we'll have tomorrow's class period to work on the homework. And because it's a new topic, I was semi-expecting you to need a decent amount of help with it. So, not that it's necessarily difficult, it's just, it's new, it's different. So you're not going to be used to the symbols or things like that. So piecewise functions pretty much are always called piece functions. Has anybody in here heard of them or done them? Okay, that's kind of what I thought. They're basically multiple graphs. It's pieces of other graphs. I mean, that's why they're called piece functions. So it's a single function that's made up of pieces of other functions. Perfect. We have everybody here today.
To be fair, I had to go back because I forgot to feed my cat. That's why I'm late.
Okay.
I was gonna come on time. Then I realized that I didn't feed my cat.
You didn't want your cat to suffer. Is it an old cat?
No, she's a kitty.
Oh.
She's 8 weeks old. Yeah.
Oh. I was going to say your cat can suffer because they'll be fine, but a kitten probably not. That's really young, isn't it? It's like hand tiny still.
Very tiny. Her name's Fuchsia. She's a baby.
What was the name?
Fuchsia.
Fuchsia.
Like the color fuchsia and the flower fuchsia. Very big flowers.
I've heard of the color. I have no idea what color it is.
It's like a pinkish, like magenta-ish color.
I know pinkish. I don't know magenta.
It's like dark.
Like what? Dark pink. Okay.
Yeah, it's like.
I'm not good at colors. No.
Yeah, it's like a pink. Oh, it's also a plant. It's also a flower.
I should have known the flower. My mom owned a flower shop. I should have known the flower.
Shrubs or shrubs.
Okay, are we ready to start a problem?
No.
Where? Oh, okay. I'll wait.
Fuchsia operating system.
So, because these are new, what I'm going to do is I'm going to show you a completed problem first. And then essentially our goal is going to be to do one together from the beginning. But I'll show you a completed one first. There's different ways to show piece functions. Like you can write it out as an equation or you can graph it. Kind of continuing on from Fridays, which probably was the easiest section you're going to have forever. But let's talk about the plus side of 9.1 for your perspective. There'll be questions from there on the test. So, yeah. I mean, like the test will be on 9.1 to 9.4. So 9.1 will undoubtedly be the sort of free points. Okay. This is what they would look like as an equation, which is on the left, as a graph, which is the middle, and as a table, which is on the right. Now, the table is not necessarily a huge benefit or help. Why do you look at me like that?
Eye contact when people talk is how you learn new stuff.
How are you writing it down?
I already did.
I just put it up. That's why I thought it was weird you were staring at me. Now, you don't, I'm not expecting you to just write anything and everything down either. But I was assuming you'd want to write, at least one of these down because you've never seen what they look like before, and I'll wait to explain them. The graph is usually the easiest way to see that it's made up of pieces. I realized I forgot to put what I wrote in green on there. But that's kind of how you're supposed to read it. I feel like Angelina really wanted to roll today so that she wouldn't get called on again. Okay, I see. This is actually a pretty good strategy. Okay, do you want to roll? I thought for sure you were calling 1-6 right away. Hank, on Friday we talked about functions again. Do you remember how to tell if something is a function by looking at a picture? Do you remember what the vertical line test is?
Yeah.
Okay, so a function is like a specific kind of graph. Do these pass the vertical line test? Yeah. Because if you take your finger and move it along anywhere on these pictures, even at the spots where they kind of look like they overlap, one of them has a missing spot, one is filled in. And so these all pass the vertical line test. So literally in their name, they're called piece functions. So every single one of these is going to be a function. And if you draw them right, you should never have lines above each other, because each one of them should pass the vertical line test if they're done correctly or set up correctly. So that's the first thing I did want to mention, and I don't know if you noticed it or not. If I look at the equation portion on the left, piece functions will have a brace that kind of groups together all of the equations it's made up of. So like this piece function is made up of 3 different equations or functions. And then, depending on where you read or see these are usually called the condition, like the conditional statement or something like that. It basically is telling you where each function is. So this one says it's going to be the equation y equals 5, but only from 0 to 13. And so the first line has a height of 5, and it goes from 0 to 13. Neither one of the dots is filled in because it's a less than. Then you're going to have y equals 9 in between 13 and 55. So I'm going to have a height of 9 between 13 and 55. The less than or equal to on the 13 tells me it's going to be filled in there. And then we're going to have the graph y equals 6, which is just a height of 6, only to the right of 55, or only greater than or equal to 55. So it would have a filled in circle because of the greater than or equal to. Now this one is kind of uncommon because each one of the functions I picked was just a number. And I kind of did that so that it was more obvious, I guess. Usually the equations aren't just going to be regular numbers. Like the one down below, I wrote actual equations for each of them. So like for the second one, I don't know if I should scroll this up. For the second one, I'm going to have the equation y equals 3x plus 4, but only before 5. So I'm going to graph this like a regular line. So I'm going to have a y-intercept of 4, a slope of 3. So I'd go up 3 over 1. Oh, wait, I forgot I went by a weird scale. Up 3 would be barely going up, but I would go over 1. And then I could do that more than once if I wanted to, but I know that this line would stop at x equals 5. And then it would be an open circle because this is just a less than symbol. Now, I would say this one is usually not too bad for most people to graph because you're used to it, like you had a y-intercept. The bottom equation is harder to graph. So you've got y equals x squared minus 3. Angelina, we should call on somebody for this one. Call on a pro.
1, 6. Oh, that is wrong. No, it literally says it. It literally says.
I like how you just like rolled.
No, it does.
Okay, Rocio, which is okay. She called on a pro. Do you remember what x squared looks like as a graph? No? A parabola? U. It looks like a U.
Oh, it looks like a.
Yep. Do you remember what the minus 3 would do? A transformation?
Oh, that's a 3. I thought that was a 5. That's a
What kind of glasses are you wearing?
Well, I'm wearing my reading glasses because I left my distance glasses. So I can't really see the
I was going to say, I know my writing's bad. But go ahead.
Wouldn't it just shift it 3 now?
Perfect. So we would have a U-shaped graph 3 down, but then obviously it's not. So if I were to graph the entire thing, so 3 down on this graph would be right here. If I would graph the entire U, it would look like that. But I only wanted the U graph to the right of and equal to 5, which means I don't want anything graphed to the left of 5. But how do I figure out exactly how high it's going to be at 5? Can anybody think of a way? It is not infinite high at 5.
Oh.
Just at 5. If we went to the right, yes, it goes up forever.
Oh, we're going to the left?
No. How high would that graph be at 5? How do we figure that out? Theoretically, I could look at that table.
Oh, you do the table. You see
Okay.
what 5 is.
So to figure out how high it is at 5, I would plug 5 into x squared minus 3. That's an eraser. And then that would tell me it's at a height of 22. So over here, I know that it's going to look like a U, but it's basically just going to be the tail end of the U. And so what I do is I plug in 5 to find out how high it would be, make a solid point at 22, and then draw the tail end of the U. That's going to be the hardest part for most of you to get down, like to get used to. Absolutely, you are 100% allowed to do it the way I did it the first time, where I drew the entire graph, draw the entire graph, but then erase everything that's not to the right of 5. So I only want to keep my graph to the right of 5, so I erase everything to the left of 5. Now, I don't know how, I tried to pick semi-straightforward examples for you guys, but maybe I didn't. How is this 0 to 5 seems to you? Okay. All over the place. Kind of what I expected because it's a new topic. Okay, let's roll and call on somebody. Two, one. It's like every day, Grant. How is our tabulation of this dice here? Are we getting like multiple repeats?
Yeah, 1-1 is the most called, 1-2, and then just all over the place. 5s, like 1-5, 1-7, 2-2, and then 4-6 has never been called.
Surprised nobody moves there. Though literally the only desk in this room that doesn't have a student. I'd say that's perfect. Okay, Hank is regretting choices right now. Okay, Grant, if I go to make a table, you'll notice I just picked some random numbers. Let's say I pick the number 15. Oh, I suppose it matters which one we're doing. Let's do this top one. If I pick the number x equals 15, how do I know which equation to plug it into? Because I've got 3 equations. How come?
Because that goes in between the 2 numbers.
Good, very good. So if I pick x equals 15, x equals 15 is in this section. Because this section is for the x's between 13 and 55. So if you're going to make a table, this little condition, the right-hand side over here, tells you which equation to use. Does that kind of make sense? Okay, Angelina? Melina? If I pick x equals 55, how do I know which one of these two to use because they both have a 55 in them? That's where it gets weird. Are you unsure? All right. Do you want me to start over?
Yeah.
Okay. If I pick x equals 55 and I'm trying to plug it into this piece function, usually the number you are plugging in will tell you which one of the equations to pick. If I see x equals 55 is written twice, which one of those 2 equations would I plug 55 into? Because it can't be both.
The bottom one,
How come?
because the top one says x is less than equal 5 and it doesn't say it's equal to 55.
Perfect. That's what I was looking for. The bottom one has an equal to symbol on it. That was a good recovery because I could tell you were not paying attention one bit.
No, he was trying to talk to me about something and I had no idea
What are you doing? Why are we distracting her? Usually she's distracting everybody else. If she's on task, you got to keep her on task. Okay, I think I'll go on to the next page, but I wanted this up here to start with because I want you to know what they look like to begin with, because if I just give you a problem and tell you to make one, you'll probably be lost. Okay, here's a full problem worked out. This is kind of why I figured today would be a lot of, like, you even just learning what they are. Are you guys getting worn down already? Morgan is about to fall asleep. Mother's Day too long for you or what? Really? How come you don't? How come you didn't ask?
It was just the first day.
Oh,
Yeah, exactly what she said.
I don't know what questions to ask. I'm not lost.
okay. I asked people how this is going 0 to 5.
I gave you a 2.
I give you a 2.
I gave a 2.
I'll give you a 4.
Okay, but a 2 doesn't mean you're lost.
Well, I understood the fact that they were in pieces.
Yeah, that's all you need to get for now.
Okay.
So the whole point of a piece function is that it's going to fit situations that have different parts to them. So like this graph is for a triathlon, or this problem is for a triathlon. And so you do 3 different events. And each event is going to be done at a different speed. So swimming clearly is a lot slower than biking. And then running is basically in between, probably. Swims, yeah, here it is, 100 miles? Oh, God. That's rough. Swims 2 miles, then bikes 80 miles. Is that really how long they usually are? I thought it was usually like 25 or something. Does anybody here do triathlons? Parents do it?
I mean, they're usually like either 50 or 100 from what I've done.
Okay, 100? Wow, oh God. Okay, and then they run 18 miles. I mean, like, I'm getting kind of tired reading this problem. Sketch a graph of David's distance versus time. David, impressive. Huh. Then write a piecewise function for the graph. Now, you don't have to make a table. I know that table is there for your benefit. And I will tell you that this column, this column isn't needed. Okay, but we want to make a graph that demonstrates the different events. Because it's made up of different events, it's going to have different pieces because there's 3 different speeds. So he swam 2 miles in 1 hour. So you'll notice down here, the first point is 2 miles at the 1 hour mark. Then he biked 80 miles in the next 4 hours, which is awfully fast. 20 miles an hour is a pretty decent speed. I mean, I drive 20 a lot of times. But it's pretty good timing. I'm just glad it wasn't mine. So if he swam 2 miles first and then biked 80 miles, where would the second point be at? How far away from the beginning of the race is he? He'd be 82 miles. Because he swam 2 miles and then he biked 80 miles. So, like, think about the starting line being at the beginning of a lake. He swam 2 miles to the other side of the lake and then apparently biked 80 miles somewhere else. So this point would be 582. Because it is 4 hours after the first hour he swam. And then we're told that he ran 18 more miles in 3 hours. So 3 more hours would mean this is going to be at the 8-hour mark. 18 more miles would mean that this is the 100-mile mark. Are we okay with the graph, or is it totally lost? You guys are real bad at asking questions. You're real bad at even just saying I'm lost until you were called on.
I'm lost.
Okay. I'm trying to figure out what to help or explain more, like,
I'm just confused, where the numbers are, oh, never mind, oh, wait, no, I'm lost.
where the numbers are coming from?
Yeah.
Okay.
Where some of them are coming from.
Okay.
Did you just graph what the points are? Like, did you?
Are you talking about the table?
No, like the graph. Are those the actual legitimate points?
Yes.
Okay.
Because if he swam 2 miles in 1 hour, the first number stands for hours.
Okay.
Second number stands for how far away from the starting line he is.
Okay. I
So-
couldn't read the top number, that's why I asked. I couldn't tell which one was which.
Oh, my bad. And then when he biked 80 more miles in 4 hours, so you would add 4 hours onto the 1. And we're now 5 hours into the race.
That says 82, I thought that said 80. And that's why I was confused.
It does say 82.
Okay.
And then he ran 3 more hours, so we'd be at the 8-hour mark. And then he ran 18 miles, so I add 18 onto the 82 that we've already gone, and we'd be at 100 miles.
Okay.
So all I did was just draw how fast he was moving during this race. I kind of wrote what was stated.
Okay. I thought you solved something to get that, and I was confused where you got that.
Nope, definitely didn't do that. So the bottom part we have to solve stuff, which is where I was expecting it to be hard.
Okay.
Alex, are we okay with the graph?
Yeah?
Yes?
Yeah.
Don't need anything explained.
And I got these examples.
Okay. I mean, like, I'm happy to explain more. You guys have to kind of learn that it's sort of, don't expect me to be a mind reader. I'm really bad at picking up on signals. I'll be honest. I hardly ever notice when you guys cut your hair. Somebody had a different color hair for a week and I didn't really realize it. I'm bad at observing things. Granted, your teacher should not be, like, acknowledging this, but that's okay. I've got plenty of flaws. But the older you get, the more responsibility is for you to acknowledge when things aren't going well and say so or ask about it. Okay, the part that you're going to have to do that is harder is the equations at the bottom. And that's what I wanted to take the time to explain. Oh, I know, that just brought on many yawns right there. Monday morning, I'm sure you guys wanted to learn about piece functions. It was top of your list. I mean, like, you should at least be a little bit happy. You have a Flex Friday coming up.
That's this week?
That is this week.
Feels like having to do Zoom meetings to have two teachers.
Shh.
Oh, yeah.
And not only that, my calendar is on the end days. My calendar doesn't even go to the bottom. That's how few days we have left. So you should feel good. We got this. This is when even those who are burnt out can start having life and energy again because an end is in sight. Well, you're in luck because you have next year too.
Next year's gonna be awesome.
Yeah, see?
Next year's gonna be awesome.
Okay, how did we get this first equation? Angelina, somebody's going to tell me how we came up with this first equation. Kayla? So I was hoping you could help explain what 2t meant. This is supposed to represent the portion that he was swimming. How did we come up with the equation of 2t?
Because, because he swam for 2 miles, and that's, D is the distance? Or is it just a random variable? I don't
Did you say d or t?
know. D,
Oh yeah, that does stand for distance.
right?
Yep. No, honestly, what you said was perfect. He swam for 2 miles over the course of an hour. So how fast is 2 miles over a course of an hour? In terms of miles per hour.
Hold on, I can't think. 2 miles in 1 hour is 30. No.
Whoa!
Hold on.
Did you just say 30?
2 miles in 1 hour? I'm sorry.
Let's translate. You are way overthinking this one. There's no question in my mind. What does MPH stand for?
Miles per hour.
Okay, let's stop there. How many miles did he swim in 1 hour?
2 miles an hour. He's going 2 miles an hour.
There we go. So he swam 2 miles in 1 hour's time, which could be better called as 2 miles per hour. Yeah. I won't lie, you kind of made my morning with the 30. Were you just like cutting 60 in half or something?
I don't know what I can't. I'm so tired.
Understandable.
Like 30 minutes for an hour?
I don't know, it doesn't matter. Oh yeah, I suppose you could have divided by 2 to get 30, like half of an hour. Like maybe that's what you were doing. I don't know. I liked it. It was very unexpected. It caught me by surprise. I like that. Okay, so 2t is 2 miles per hour. So t represents the amount of time in hours. So the slope is your speed. You're going to get a question just like this. That's why I'm trying to explain this. Homework and test. So the speed is your slope. Okay, and then he went biking. Now the biking one is kind of weird because we don't start at the origin. So I can't just say 20t. Now, I know it has an answer here. I don't know if we should roll somebody for this or not. Oh, wow, you guys are mean. Okay. Roll somebody for this. Do you remember how to come up with an equation from 2 points? I'll honestly be really impressed if you do. That's why I was just trying to call on Ren. Like, I didn't want to have to roll somebody, but they had vengeance in their heart today. Maybe you mean it correct? Can anybody help him out? Does anybody remember how to find the equation with 2 points? Okay, you're probably going to want to put this in your notes and highlight it. You're going to end up using this, and so that would be the main reason I'd want you to, like, it's difficult to memorize. So, like, I'm not That's why that's why I thought it was kind of cruel to just call on somebody by rolling. This is how you're going to come up with the equation from 2 points. There's multiple ways to do this, but this is the most common. And you basically find the 2 points that start and end your line. And honestly, it can be any 2 points. It doesn't have to be beginning and end. But that would give you the equation of a line. So if I plug in 582 and 1, 2, I would write y minus, y1. Okay, I'm going to make the smaller numbers 0.1, the bigger numbers 0.2, because I don't want to use 82. So y minus 2 would be 82 minus 2 over 5 minus 1 times x minus 1. So this would be 80 divided by 4, which is 20. Rocio, if you need to, you could sit in there's one open there, like if you're that blind. So there's different ways to come up with this second equation, but this is how they did. They took the 2 points that begin and end the bike segment, and they came up with an equation for it. And then the exact same thing was done for the marathon or the running segment. They took the beginning point and the end point and came up with the bottom equation. So your homework for this section is not going to be many problems because this goes slow. I mean, just know that ahead of time. And this is also why I was expecting tomorrow would be our homework day, that we could work on it together, because I thought you might need it or want it. Yeah.
Jake wants that extra.
I also know there's some people who, are doing pretty well and probably are possibly already started the homework. That's fine. Okay, last thing on this problem. This is going to be a long video today. Last thing on this problem, how did I get the stuff on the right? How did I come up with that? Is this considered a hard question? That's why I didn't know if we should roll or not. No? Okay. It's, wow. Rolling is tough on a new topic because a lot of people have trouble with new topics. Let's roll and I'll basically walk somebody through it. Yeah, shake it in your hand first. That's what I've definitely noticed has needed to be done.
Row 1C8.
What's with row 1?
Why do I never get called? Does the next call roll?
Alex is basically asking to be called, apparently. Why didn't you just volunteer then?
Why would I volunteer?
Well,
There's a roller for a reason. I'm just
okay.
gonna be called. I'm ready to go.
Do you want me to walk you through this one? Do you feel like where did these numbers come from? Nothing. Okay, so the swimming portion was first. How long did the swimming portion take? Oh, I suppose it's up there. 1 hour. So basically, from the beginning of the race until the end of the first hour was swimming. And so the first segment was from 0 to 1. Now, it doesn't matter where you put the equal to symbol. The equal to symbol could be on either one of these. It just can only be in one spot. Like if you want to write the equal to symbol as the first one every time, go for it. Okay, how about the second one? How did we come up with 1 to 5?
What's the second part?
Took how long?
4 hours.
4 hours. So since the second part took 4 hours, I went from the end of the first hour, which was swimming, and I added 4 hours on. So it went 4 hours past the 1 to 5. And then the third part took 3 hours, so I added 3 hours on to the 5 to go 5 to 8. The second part is supposed to just say when it happens.
What does the minus 18 and plus 52 have to do with that?
Because those lines don't start at the origin. So the minus 18 and the plus 52 take into account that they've already done some segments before. So if I give you any time length, like at the 7 hour mark, I want to know where this person would be at. So the 7 hour mark would take into account the swimming, would take into account the biking, and then would do 6 miles per hour after the end of those. So that's what the plus 52 is for. It's basically taking into account how many miles he's traveled beforehand. Okay. I'm just going to lose my voice here soon. What do we think? Let's do this one tomorrow? Let's do this one today. I told you we had an hour. No, so I wasn't like... Maybe what we can do tomorrow is we can just do that question together, and then you have the homework for the rest of the time. Okay, this one, I don't think you need to write all of them out or do any, like, I just want to go over one of them. So let's do A and D. Oh, okay, A and D. Yes? No? Angelina, we know somebody can help us with this. Thank you. I don't think she was rigging it.
No, it has to be. I don't know how to do it.
It's a good thing you wanted to be called on. Okay, so I can walk you through it though. So this piecewise function says the equation that we would use is -8 for every number that's smaller than -5. We would use the equation 0 for every number between -5 and 5. And then we would use the equation 5 for every number bigger than 5. So this one says find the answer for -6 and 3. So the way I would write this is I would say f of -6. How do I know which one of these three to plug -6 into? It kind of says. Which one is, which would -6 fit into here, here, or here?
-8.
Perfect. So the answer is -8 for every number smaller than 5. So f of -6 is -8. And then it says find the answer for 3. So f of 3, which one would 3 be plugged into, Alex? Top, middle, or bottom? Middle, because 3 is in between -5 and 5. So the answer would be 0. Now, if it was an equation like b, then you would just plug that number into the equation. But this equation was a number. Okay? And then what did we say? D? Okay, last one. I'm trying to get a lot in because I'm gone Thursday for a doctor appointment, so I need to get all the work in today and then Wednesday. Wait, you guys You guys are Thursday, aren't you? Okay, so I'll just tell you now so I don't forget later. Because I'm gone on Thursday for a doctor appointment, on Wednesday when I teach the other 2 algebra classes, I'll record that one, and that's kind of what you're going to have to go by for Thursday. So do your best on Thursday. On Friday, on Flex Friday, I'll be available if anybody wants to meet over video to go over those problems, but otherwise I'm going to go over the section again on Monday. So you'll still have time for everything. But just letting you know I won't be there Thursday, so you kind of have to go by the video that I record. Okay, Angelina, last person.
Row 3, seat 7.
Do you remember how to graph negative 2x plus 8?
No.
Good help, thanks. No, I'm just kidding. I'm going to go by 2's here just to get it to make a graph, I guess. Do you remember what the number, God, you know what, it's really hard to talk and do things at the same time. I don't know how you guys text and walk all over the place.
Well, it's simple, you just walk into the wall.
So 2, 4, 6, 8. Anna, do you remember what the number by itself does on a straight line?
It would go up 8.
Perfect. So that's the y-intercept. So that tells where it crosses the line. So it starts at 8. And then this number on the x was the slope. Do you remember what slope does?
So down to left 1.
Close. Very close. The fact that you went down to, that was the negative part. And then you go to the right one.
Right 1, okay.
Yep, so I will go down 2 to the right 1. Oh, that's still right there. Okay, so I'm going to draw this line and, I don't know, have something. But I don't want the line, I don't want the full line. I only want the line to the left of 4. So I'm going to go erase everything that's to the right of 4. And then this has a less than or equal to symbol, which means it's going to be filled in. Now, I might need to know where... Hello? Sure, can you wait a minute? Oh, okay. Okay, Hank, Morgan. What did my class do on Friday? Oh, she's, okay, good. You had me worried. Yep, bye-bye. She told me she had a whole list. Go down to the office when we're done. Okay. If I want to know the height of this point at 4, I would plug 4 into the equation. And I would have negative 2 times 4 plus 8, which, oh, my picture's way off. My height is supposed to be 0? Maybe I should have done that first. What? I should have definitely done that first. Hey, look it. I got a perfect picture now. Got erasers. That's what erasers are for. Okay, so it stops there. And then, I don't know if you know this, Anna, how would I do the second half? How do I graph 1/2 x?
Can you explain?
You don't know?
No.
No what?
Swearing is just so secondhand to you that you don't even know when you do it?
Oh, yeah, I just remembered I forgot something.
Yeah, we all heard.
Oh.
Yeah. It's probably on the recording. Okay, I'll just finish it so that we can be done. 1/2 x. It's going to start at 0. I'm going to do this in a different color so it's easier to tell. It's going to start at 0 and go with a slope of up 1 over 2. and would keep going like that forever, but I only want to draw it after 4. So I am going to start it there because I don't want to draw it to the left of 4. And so there's drawing a piece function.